Assalamualaikum. We are from Group 13 who would like to present our PBL task. First of all, I would like to explain the objective for this PBL task. First, we need to design the power factor correction circuit. Second, we need to stimulate power factor correction circuit in the multi-sim. Third, we are able to compare the value in simulation and calculation. Last but not least, we are able to understand and analyze the concept of AC circuit.
Question given for task 1, we have construct the circuit like this. This is for load 1, load 2 and load 3. Calculate impedance in each load. We have to find complex power in each load. Since the voltage at load 3 has been given, so we have to solve at the load 3 first. 3, we will get the complex power since the real power, which is P, and the active power Q has been given. After get the complex power, we can find the impedance at load 3 by using this formula. For the next question, ask us to find current, voltage. So, we will find the current, voltage and so on at each load. For the load 3, to find the current, we have to use this formula. And also, to find the voltage at load 3, we will use this formula. We will proceed to calculate impedance at load 2. There are real power and power factor given. By using this formula, we can find reactive power, which is Q, so that the complex power can be found. So, by using this formula, we can find the impedance at load 2. To find the current, we use this formula. And to find the V total 2, we use this formula. Next, step to find impedance at load 1 is same at the load 2. Since real power, which is P, and power factor has been given same like load 2. Total, we can use this circuit, which is the formula is this. Total, we can use this circuit, which is the formula is this. For the question B, we have to find the Vs. So, we are using this formula to find the V supply. Since the Z total already been calculated in the previous calculation, we only need to find the I total. For this figure, we have already know I total is equal with I3 plus with I load at load 1. So we need to find the I load 1 since the I3 we have already calculate. So to find the I load 1, we have to use this formula. And lastly, we can calculate and get this V supply. By using this figure, we can find the current in each load. We have named the current in each branch, which is I total same with I1, I at load 1, I3, I at load 2, and I4 same with the I load 3. So, we have in the previous calculation, we have already calculate I total, I3, I4 which is I load 3 and I load 1, and we can get at I load 2 by using this formula. Question D is asked us to find real power and reactive power at each transmission line. So in each line we use this formula, which is Q, and we use this formula to find the real power. Question E is to find total apparent power, which is S, total real power, which is P, and total reactive power, Q. And we need to determine whether the system leading or lagging. So we need to use this formula to find the complex power. The value in imaginary, we automatically will find the P and also the Q. So we just need to find the power factor whether the system leading or lagging. So this is the complete power triangle. We can find the angle in the power triangle from the power factor angle.
For task 2, we have been asked to design the power factor correction system that helps to improve the system power factor to 0.98 lagging. So, this is the step 1. This power triangle are been obtained from the previous calculation. We name it as old power triangle. Step 2 is for calculate the new power triangle. Since the new power factor had been given from the question, we can find the value of mu theta. Since the value of P and Q are being calculated, we can easily find the value of S, which is the new complex power. So, this is the new power triangle that have been calculated. Next, step 3, we have to combine the old power triangle and the new power triangle to determine the reactive power for capacitor. So, we use this formula to find the value of capacitance.
For task 3, we are required to simulate the single line diagram of distribution line. So, we need to convert the transmission line load diagram into a circuit diagram. Therefore, since we have the value of impedance in each load, and those values of impedance has been obtained from the task before, which is in task 1, then we need to get the value of resistor, capacitor, and inductor of load and on the transmission line through this impedance value. As we can see, in the impedance values, there are real and imaginary values. The real number shows that the value of resistor, while the complex number is the value of reactance. So, reactance can be capacitance or inductance. If the value of imaginary is in negative sign, it shows that the reactance is capacitance, while if the value shows positive number, it indicates that the reactance is inductance. By using the capacitance formula, which is Xc equal to 1 over 2 pi Fc, we can find out the value of capacitor. Then, to find out the value of inductor, we can use the formula of inductance, which is X equal to 2 pi Fs. The table shows that the capacitance or inductance value that have obtained from the impedance of load and impedance in transmission. Since we have all the values of R, L, and C obtained from the impedance, then we have to apply them into the circuit, and for our task, this is the circuit diagram that we have figured out. In this circuit, there is capacitor that is parallel to voltage supply. This capacitor is required for power factor correction, as power factor in this system must be improved to 0.98. The switch will be turned on for simulation of power factor correction later. In this simulation, we place the probe of current and voltage on each load. This is proposed to measure the power on each load. At the part of the series to supply voltage, We also place the voltage and current probe to measure the total power of this system. The result is analyzed in graph view of single frequency AC analysis. As the result shows real and imaginary of apparent power of the load. In the graph view, from line 9 until 13, it shows the value of power of load 1 until 3 respectively. At line 14, the graph view shows the total apparent power of the system. If the graph view show result in real and imaginary both, the real part of the values indicate real power while the imaginary is reactive power. If the graph view is in magnitude or phase mode, the magnitude and phase shows in apparent power in polar form. Besides, we also place voltage and current probe in the transmission line to prove that the calculation is correct. And this is the data that we have collected from the calculation part and the simulation part. There is only a slightly different of calculation result and simulation result. For the power factor correction, the switch is turned on. This is purpose to make the capacitor parallel to the power supply. And then the total power of this system is measured again, and there will be changes of real power, apparent power, and reactive power of the system as the power factor have been changed. And this is the data for real, apparent, and complex power of the whole system after the power factor correction. This result is a comparison of calculation and simulation result after the power factor correction.
Firstly, we are able to construct the circuit based on the information given in the table. Since we are group number 13, we have to multiply with the value given in the table and get the new value for circuit based on the calculate value. PBL task, we had identified that the calculation can be affected by some error. Calculation error, which is, for example, value in calculation is slightly different among team members because of differences of decimal places. Last but not least, the value of calculation and simulation also been compared. Both results have slightly different due to the construction of component on the multisim. Besides, due to this PBL task, we need to use the latest version of multisim software because we need to measure voltage and current by using probe instead of multimeter. In addition, is simulation component. For example, we actually use AC voltage instead of AC power for the supply so that we can get the same value as calculation. We also had to use AC voltage because we need the value voltage to be measured in peak and not RMS value. Last but not least, the value of calculation and simulation also been compared. Both results have slightly different due to the construction of component on the multisim.
As conclusion, we are able to learn how to apply power factor correction. For the application of power factor correction, we need to improve the power factor correction for transmission line by increasing the power factor near to 1. We need to install the value of capacitor that we obtained from the calculation near to the load.